a 19 late as always. Do it. File up. Alright, so your scans showed the lava did indeed form obsidian. The wind changed direction enough to stop sending lava drops towards you. You and the elephant cave, and as you do, you notice around the pond. Perhaps you can use the obsidian to create some geode cracking robots and break them up. Like obsidian from the bottom of the pond. You'll need waterproof collecting obsidian robots. Fortunately, there's an abundant amount of clay nearby that can be used to make them waterproof. In order to harvest the clay, you'll need special purpose clay collecting robots. To make any type of robot, you'll need ore, which is plentiful, but in the opposite direction from the clay. Collecting ore requires ore collecting robots with drills. Fortunately, you have exactly one ore collecting. We need ore to get clay to get obsidian. Okay. Each robot can collect one of its resource type per minute. It also takes 1 minute for the robot factory, also conveniently from your pack, to construct any type of robot, although it consumes the necessary resources available when construction begins. The robot factory has many blueprints, your puzzle input, and you can choose from, but once you've configured it with the blueprint, you can't change it. You'll need to work out which blueprint. Blueprint 1, each ore robot costs 4 ore, each clay costs 2, obsidian costs 3, 14, okay. Blueprints have been line wrapped here for legibility. Okay. So each line is just 1, and there's oh my. The elephants are starting to look hungry. You shouldn't take too long. You need to figure out which blueprint would maximize the number of open geodes after 24 minutes by figuring out which robots to build and when to build them. So in using blueprint 1 above, the largest number of geodes you could open in minutes is 9. So you start with an ore collecting robot and you collect 1 ore, then you have 1. Collect another, you have 1. Spend 2 to start building a clay collecting robot. 1 ore collecting robot collects 1 ore, and now you have ore. The clay collecting robot is. Now you have 1 of them. Okay, they're both collecting. Yeah. It's clay collecting robot. You have 3. I kind of get this, but let's just go and parse this real quick. So, sorry, there's ore robot costs 4 ore. Each clay robot costs 4 ore. Obsidian robot costs 4 ore and 14 clay. Geode robot costs. Okay, so there's like 3 resource types for. We're trying to get geode robots. What's the end of this? So 1 geode collecting robot cracks. So 2 robots crack 2, and now you have 9. Okay, however, by using blueprint 2, you could do even better. The largest number of geodes you can open is 12. Determine the quality level of each blueprint by multiplying that blueprint's ID number with the largest number of geodes that can be opened in 24 minutes. Second blueprint has whatever. Determine the quality level of each blueprint using the largest number of geodes it could produce in 24 minutes. So the second largest is this. You add up all the quality levels, you get 13. What do you get if you add up the quality of all blueprints? All right. So data class. So say val ID is an int, and then they're always this format, right? So it's or in clay, or in obsidian. So I can just do so for robot cost is an int. I wonder if actually we should check our input just to make sure it's actually or clay or an obsidian. They're always that. Okay. So val robot cost is an int, and val hey, what's going on? Obsidian cost robot cost is, I'm gonna say a pair of ints, and then val geode robot cost is a pair of ints as well. Okay, it's pretty long. And just hit some buttons and format it like that. Yeah. Okay. And then say fun parse input. We're going to return a list of blueprints. This is going to be return lines.make. Okay, so the first one is AL like this, and I think we can split on like they're all the same, right? Actually, we can just use our frickin' hacks, which is L dot nums equals L dot all ints. Yeah. Because of course we have a thing for that. So nums 0. I'm actually going to turn this to n. Can I just do n dot? No, it's not going to work actually. This. That. Okay. So 0, 1, 2. Sorry. 3, 4, and 5, 6. So, and 4, and then 5, and 6. Okay, and I'm gonna say debug that. Make sure that we just kind of get all of though. Calling is important. So prints equal. Okay, and this didn't work. Cool. Why we red make dot why did my all ints? Oh, because I didn't frickin' copy the test input. Come on. Just come on. I guess I can just do this. That should give me a 4. Oh. Should pull it over here so I can see all of them. Okay, so let's just make sure we have one for 2, 3, 14. 14, 2, 7. 12. Okay, that's good. Okay. Now what we need to actually do is we just need to walk through it. So we're gonna do the kind of thing we did today, but not screwed up this time. State, and the state is going to have, just do them as val resource count, list of int, val robot count is the list of int. I'll be regretting this soon. Back. So these map 1-to-1, so clay. Okay, the clay one costs something different, but that's fine. I think. I think this is fine. So simulate, or I'll say find best is going to take in state, val state, and this is going to return a long at. So this also needs a blue pen. Oop. Okay. And so we're just gonna say this is to do, and then what we want to do is we want to so state also needs to know okay. No long. I'm gonna say it a state. What is the state? Initial state. Let's see. I'm already regretting my thing. Okay. So this just says minute 1, whatever. So I'm gonna do so state 1, then the mutable list of I don't think we start with it, right? So there's obsidian, clay, ore, clay, and so ore, clay, obsidian. I don't think we start with any. Double check. Double click ore, you have 1. So we start with nothing. And then robots, right? So we also mutable of int. We have 1. Why is this satisfied? This is not right. So best score, and then needed to multiply the best by some. Let's see. Determine the quality level by multiplying multiplying the ID number with the largest. Okay. So it dot return it dot ID times, and then we'll sum these. Too long. Pretty cool. I am not understanding. Nothing. Oh, because I have this return. Yeah. Okay. That was kind of weird. It's because in Kotlin, you can return out of one of these like nested things, and it actually means out of this. So if you want to return from the map into the map, you have okay. And then this is the same kind of thing the other day. It is a decision tree. Okay, so what we want to do is we're going to say get resources. If we then make decisions, and this is like okay, let's just get the resources first. So val new resources equals, and we're gonna do state robot count to list. Give us an does, but sure. List. This does make copy. And what this is saying is for every robot that we have, we're just gonna get another, right? Do they map? So clay maps. So for clay, obsidian, geode, and we actually care about the last thing in the list. We actually want another okay, and this actually needs to say if state equal state dot time equals 4, I think. Then we'll just return state dot just count dot 1, 2, 3 belongs. That makes sense. Or I'm just belong it here. Okay. So this is our new resources. So we'll just say val state. Just make sure I understand this. Do we get the resources at the beginning, or I'm assuming we have to commit to building the thing. We have 2, then 2 to start building. So we have to make decisions. We actually have to do that here. So, okay. So let's see. For okay, so the options we have are build something we can build, or build any combination of the things we can build, actually. Because if we can build more than one thing, we can build more than one thing. Is that even possible? I guess it's possible to have enough play or whatever. So, okay. So let's see. Make a list of lists of the types of robots we could build. This might actually just be one thing, but I'm not really sure. So for what kind of blueprint dot? Okay, so I have all these costs. So var branch list equals mutable list, and this is going to be just a mutable list of states, actually. So we're going to do this, and what we're actually going to say is if blueprint dot let's just go through them all like this. Or cost is less than state resource count. So we have to be looking at what we have right now, right? Or we had going into this one, right? Let's just say branch list. Add. So we're going to say state dot. So we would, what would this be? We'll just assume we can only build one, but that might be wrong. But state dot, val new time equals, do the easy one first, right? Okay, and val new resources equals list of. Okay, so the or always costs or. So here we can state dot resource. Actually, let's just do this. State dot we'll do state dot resource count dot zip. We're going to zip with the new resources that we're going to get, and then we'll add all of these together. So this is combining the resources. So in the check, we're using the last state, but in state, we want to combine them in fact. We'll do this. We'll do okay, and then we'll say new resources 0 minus equals okay. No, 2. I am so confused. I'll just start calling it whatever. There we go. Okay, and then we add a new state that has new time R1 as resources, and then RC1 equal state.robot count to list, then RC1 this that so okay. Alright, so now we're just gonna go through all of these. It should be clay count. We're gonna check clay or as well, I believe. Yeah. Okay. So this is the same. This is the clay count. This is still val, and this is 1 because that's what we're doing. So we're subtracting from obsidian here, and we're adding 1. That's good. Let's go on to the next one. So then a little bit annoying, but try to shrink down a little bit. So obsidian costs, yeah, so we're doing 4 and is the cost check. First, make sure we have enough clay, and then this is, I really hope I don't frickin' screw something up here, because this would go quite badly. And so we're subtracting obsidian from ore and clay first and second. Add 1 obsidian. Still the same things. Then first against obsidian, second. Yeah. And what is it? This geode cost is going to be against 4 and obsidian. So that is 2 here. Subtracting from ore and obsidian. Head over to geode. Do this 3. We actually got the resources up there. Then down, any of this can be. We're just gonna call find best move turn branch list dot of find best move of blueprint, and that's okay. I don't know, work. Nope. Oh, and you actually always have to add the state where we just get resources. This. So new time. The resources are just this. I'm just gonna R0. And then the robots that we have are just the same. Okay. That seems bad. Alright, yeah. Yeah, so this is not supposed to output 0. So it is supposed to output score should always ever adding. Alright. So okay, let's take this one out. We're really just gonna run the first one. No, really doesn't like that. That's do filter dot is not empty. Okay, so let's just okay, so when I get here, I'm actually just gonna print and state ending. Okay, so it seems like we never get never gonna need 2 robots. So if obsidian cost, oh, this is stupid. Didn't be. All right, there we go. Which means this is gonna branch a lot, but that's okay. That's running. Let's go back and wait. So 9 minutes. Did I say 26? This should get 9, and that one gets 12. Okay. This seems like it's taking a while. So let's just do some on a. Hey, what the heck? Oh, I see. Let's actually just look at this real quick. So if you can, there's probably actually just some way to compute the best, but 314. It actually kind of seems maybe like a dynamic programming thing, but so yeah. I don't have like an So how would I cache this actually? Does it work? Probably. So probably cache. I don't know. Let's get rid of this and let's think about this for a sec. So I think this is going to take a while actually. Could be wrong. How do we simplify it though? Right? So like right now I'm creating a state every time. Vision 3. But there's not like it's kind of the same as the other day. There's not actually that many decisions, right? Or the decision points. So like if I have for or like in this first example, if I have for or, I should be right. So trying to think about if there's some sort of like graph that I can put this into. I think that's probably what I'm. So let's see. Obviously forever. And the problem is that, I mean, I guess caching could help. Like, I'll throw in a cache. Don't know that it will, but it might. Al cache map, and this is going to be a state 2. Two is you had to say this is probably dependent on each blueprint. This out. This whole thing out to say find best move internal. It's gonna have state like that, and then that makes it so I can actually just cache inside here, right? So oh, so this is going to only work for this blueprint, but what we say is if state in result and do our standard. Yep. Hash state equals return. Yeah, I don't think that much, but it could. I think the problem is that you're always going to have like kind of different like different bits, right? You're trying to do. So how can I reduce this to something that's like back to the problem? Oh my gosh. Okay. Yeah, like can't even execute one. Okay. The goal is to get like in order to get one right, you need like this sum, right? It's like 2 plus 3 plus 2 is 7, right? You also need like 7 days of obsidian, right? Like, I don't know, this is just like a standard like game. What is optimal, right? So it's like it is just text. Sure, fine. So yeah, can I math this out? Like, obviously simulating it is not working. So I think what you got to do is start at the bottom, right? Kind of work backwards. You say, in order to get a geode robot, I need 7. And so that is like if I only have 1 obsidian robot, like 7 days. Yeah, damn. Is this the dynamic programming thing? It feels a little bit like feels like it. I need 7 obsidian. Yeah, shoot, I don't even know how to go about this. So, you know, the dumb algorithm is grab a like grab as much ore, like just keep, you gotta like turtle up on your ore, which sort of makes sense. But what we really want is like the end result really is possible. That means balance. Alright, this is kind of lame, but I just like. I know it's been running for a long. Any of this. So. Okay. Yeah, this is like not a super dope stream. Sorry, I have a frickin' idea. So I hope you liking the chill. We got one. So the problem is that you like can't just go for clay or for ore, and it really depends. Like how much you need really depends on the blueprint. That's the whole. Yeah. So let's pretend we're not trying to get geode. Like let's literally pretend we're just trying to get obsidian. And I think we can do it again, right? So in order to get obsidian, we need 3 ore and 14 clay. So if we just have 1 ore here, we can like get this dude to go get 2, and then and I guess how do we know if we need to build? Like how can we do this? We can convert all of these costs back to just straight ore, right? Okay. So like what is the value of obsidian is like in this first one like 3 ore plus 14 clay, right? And like clay is worth like 1 clay is worth like 1 day. Well, it's 2 ore. This is actually kind of hard. So you have a clay, it's like, or sorry, if you have a clay, a clay robot is 1 clay times time. So if you get it, like depending on the day that you get it, it does matter, right? This is also, like the cost of this is 1 day times 2 or. And so then we can say, what is or worth, right? Say or robot is or. Or sorry, I have to do the same thing. 1 or times time. It's also 1 day times 4 or. Okay. So then you can do this with an obsidian robot. 1 obsidian times time. Okay. And the cost is 3 ore plus 14 clay. And then can we solve for clay here? Like, I don't know. I don't know what I'm doing here. I'm gonna try to. So it's 14 clay. That doesn't make sense. If anyone has any ideas here, I don't think my simulation is going. We got 1. And this does work, right? But it's obviously not work for this. I kind of think this one, where we just add to it, is probably something that we shouldn't do. I'm definitely wrong. Because you might want to build a clay. Like, if you can build a clay, should you definitely build it? Or should you maybe save up for an ore? This is like, you have one, or if you don't ever save up for what the... Okay, let's think about this a different way. Instead of trying to like convert these and be like, yeah, how do we do it? You can say a geode robot, like the full cost, right, is 2 ore plus 3 plus 2, right? And we do this by let's see, the ore. Because I think I'm just trying to figure out how quickly I can build like a bunch of, right? So yeah, so what if we just calculate how What if we just work backwards? So we have 2, 3, 2. So if we just like did the least cost, right? Be 3 or 2 or the 2 days plus 1 day. Make robot. Make clay robot. And then this is 3 obsidian robot, right? So plus 3 days. Oh no. Because we're actually collecting an ore on the day that we make the alright, use blueprint 1. Or spin or to make play. Okay. So we're still getting the ore, right? So and we need another 2 days. That's 5 days. I mean, like, looking at this, I can see, like, obsidian is frickin' costly. I think I'm trying to find the bottleneck. Not actually sure how. So maybe the way to think of this is to figure out like how many of each robot type. God, it finished and it got the wrong answer. That's freaking terrible. Okay, this is really bad, actually. I'm actually very confused. So I think I mean, I think optimal is probably actually if you have enough of the next resource up, you frickin' thing. So what if I like ideally say like well okay, so let's change this a bit. So I have this. Okay, this is like, what if I just don't spend my resources? That's kind of fine, right? Then I'm gonna say if I can make, like, if you can make one of these, you always want to. So figure out when I would want to do this. Okay. Okay, so what this is saying is like if I can make sig, definitely make it. Or sorry, a G. Oh no, are you serious? Oh, that was the issue there. That was the wrong. That was stupid. Okay, I can still improve this though, right? So, so if I'm gonna make, if I can make one, I'm definitely gonna make it. You don't need to do this every time. LR1 equal. Okay, so that makes a copy of it. This is like a state that will go in. But I might be able to make other robot types, right? Oh, maybe I can make more than one. I don't know. Let's actually just order these like this. I am glad that I finally over there. Okay. I'm just gonna figure out. So actually, let's look at this example. Start building. So okay. I'm actually val best equals 0 and say as big as best equals this. Okay. Nope. Got it. Okay, this is still very stupid though. I'm just simulating it. And best, and then I'm reassigning best. Okay. So freaking. Okay. So have we made any progress whatsoever here. Really, honestly, like I don't. I'm not sure, but I'm pretty sure that if, well, okay, if we can make yeah, I'll be like val new robots equal list. Like, yeah, I mean, this should help. Okay. Sorry, I'm trying to. 3. Like, I'm pretty sure I could get it to thing with an else if, but that's bad. I think we can actually be pretty aggressive here. So we can do this. Like, if you can do one of these, do it. So, like, instead of doing this, actually, I'm just like doing this is the best. So I'm just gonna say return. And then if I can do this one, I'm also just gonna internal. May not be a good assumption, but and then here I think this is where it gets like, we don't know, because they're kind of all competing for sources. So 0, 0. I mean, the other ones are 2, but not as best internal. Okay. Oh, cool. Now I got 0 very quickly. Make a code. Oh, doesn't do the thing. That's still the wrong term. Huh. I feel like right is not, that's not right. Okay. Val best log. So, what do I actually want here? The string. Trying to figure out what the heck. A string log. I feel like this is gonna be a late. Best log dot clear. Best log dot all log. Actually, move last. Oh, you know what? This might actually just be. Do we start at 1? Ew. Damn it, dude. Okay. Fine. I should just be like string log. I'll just right. T dot time make geo robot is obsidian these are like kind of impossible, like branch list. We'll just pair them. List string. Like that. Alright. And then this like dude. Clay log equals string log. Immutable list. Clay log dot add this. I don't know how bad this is but and then be string log dot add word 12. string log, and then this is a log, even though this should be the end log. We do this, we first it dot second fired. Useless. Okay. Really? Okay, so just don't be bad at coding? You gotta be kidding me. Oh my gosh. Okay. I just suck. I just suck at code. I'll have to legit go back. Yeah. Super and and then say result equals that, return result, and then I just want to do best log. This will take a little bit, but they should actually all run in amount of time. That's super annoying. It took me an hour and a half to find. All right. Do you actually believe that when it said best score is 0? Wonder if that's going to be part of. It is a sum. There are products in between, but it's a sum of all of them. So if some of them are 0, it's like not really a problem. But chilling here. How many do we have? 30. Second. All right, we're back. We have something. It took almost 2 minutes. Oh my gosh, we got it. We got a rank of a 730. That's what? What? All right. Whew. A lot of people are having trouble on this one then. I'll say I got lucky. All right, while you were choosing your best blueprint, the elephants found some food on their own. They're not as much a hurry. You figure you probably have 32 minutes before the wind changes direction again. You'll need to get a range. Unfortunately, one of the elephants ate most of your blueprint. Now only the first 3 blueprints in your list are intact. 32 minutes, the largest of the geode's blueprint. 1 from the example is 56. Okay. Our blueprint 2 from the example is still better. Whatever. You no longer have enough blueprints to worry about quantity. Instead, for each of the first 3 blueprints, determine the largest number of geodes you could open, then multiply these 3 values together. That's what I was saying. Like, hey, we're not multiplying anything. Multiply these 3 values together. Don't worry. Just determine the largest could open first 3. Okay, like, don't worry about quantity. Do not do quantity. Yeah. Okay. And along this, we are just going to do a 3. Don't do this. Are just reduce times b, and we need to make sure that these are longs. Not too long. Says it doesn't do anything, but right, and then time limit p equals 24 for the first one. And then part now have 32 minutes. All right, just let it go. Nope, don't run those too long. Okay. I think this is probably going to take a while, but at the large number 2. Okay. 6 and 6. Doesn't give us the answer, it just gives us what are you looking for? We're looking for 56, 60. I know. I'm not even doing problem solving actions. I'm just gonna let it go, I think. Oh no, it didn't get the best score. Okay. So what this makes me think is that one of 2 things. The first one is that we may now have a case where it's worthwhile to build 2 different robots. I think that's probably the case. If we look at this, build, let's see if there's a So they try to. We're collecting clay. Okay, you don't actually need to run this because whatever we're gonna get. Yeah. All right, let's see. So, let's take out this. All right, so we're gonna see what it tries to do, and then what we think the right thing to do is. Realm where I am supremely unhealthy. Oh yeah, thanks man. Thanks for the moral support for sure. I mean, the thing I had said was like, I just think if we can make a geode cracking one, we should do that. That's what this does. So, did I put in the right number? Did I say 32? Best. Okay. Well, I at least have what I think it should do. You like this? Hoard wealth? Hoard wealth? Yeah, okay. And... Wait, what? How's it making an obsidian robot here? That literally doesn't make any sense. I must have copied this wrong. Damn it, I did. Okay. Make for robot. Make play robot. Like, that's not even possible. Yeah, so the first one was actually pretty hard. I mean, I thought I was just having trouble with it, but not just me. Unfortunately, these later ones, man, like you don't get to see me do a bunch of coding. I'm literally just like around problem solving. But I don't know. You're a lawyer. You got to do logical stuff. What should I do? Or this is just a board game. Sorry, I keep hitting the mic. Just a board game. Tell me which token I should create to be optimal here. Okay. Maybe I should actually also print. I'm like 80% sure that I'm doing this right, but well, let's just go look at this and see kind of where it breaks down. Yeah. Where's Jack when you need him, right? One ore collecting robot, new ore collecting robot is ready. Now I have 2 of them. Okay, so hoard wealth. Then I think this is what I did though, right? 5, we make an ore collecting robot. Hoard wealth. Play. Oh no. Oh no, this is where I was like, hey, if I can make obsidian, do that. Okay. So... yeah. I think this just has to go... like... just gonna do the same thing as before. It might just take a bit longer. So I'm assuming this doesn't work very well. So branch this. So the problem with like just adding these repeatedly to the branching list, that it is really gonna start like making this take longer. But this is why we got the tunes, dude. Yeah, so we're just trying to do one. So just by adding this one thing, it basically means that we're gonna, I don't know, this could take, I mean, however many times we built obsidian, right? So building an obsidian. Yeah, so I mean, each of these is gonna 1, 2, 3, 4, 5. This could take longer. This could take 30 times. The nice thing is that it doesn't actually take any longer on the test inputs. Or when you have the like the test input, take that. So 30 times. What can we? I don't think this caching helps. Is there any like pattern matching? Shortcutting we can do for like not hoarding. I feel like we probably should only be doing that we can, there's probably some check that we can do for this, right? And this will actually prune us down a lot. We can check if basically if we have enough of these stupid robots, like if we have enough, I mean the limiting factor is always ore, right? So we only need enough ore robots. We only need enough ore robots to like power our machine here, right? And so we're only making one robot. Can you make more than one robot given day? No, think so. Let's see. Robot. It also takes 1 minute. Robot factory. Construct any type of robot that consumes. Okay, so the factory makes it sound like you can only produce one robot at a time. So we only need as much ore then as the, like you can only, sorry, it's only worthwhile to hoard resources if you don't have enough ore produced, right? So we'll just say if state dot source count 0 is greater than actually just gets up here, we'll say max or robot cost equals max of and we're gonna go into blueprint. This clay. Can I do more here? Happy. it's like, why do you? That's fine. We can just add these all to. Don't do that. We can just do list of, and then we can do max of this, right? Max. Okay. So I'm just gonna say we don't need to hoard resources if more than 2x that, or I don't need any more than like 3/4 of the max cost, or if state.robot count. So if we have enough, like if we can only make one robot per turn and we have enough robots churning out the ore, then I'll just say this though. That's like pretty what do you mean you don't? So okay, if we don't have enough ore, and robot count is less than that. Okay, then we'll like consider consider hoard wealth. Okay, does that help? This could reduce by what else can we do? Can we do this for every other one too? Probably. At some point, we just know. We're like, dude, you don't need any more of those. You actually like, you now have, what if I just do or dot? So to assuming that if you have enough for the max cost that you like should never yeah, I think that's true. I'm just gonna say and branch list empty. So once we can actually start building, like here, two ore collecting robots collect 2 ore, you have 6. Huh. Okay, maybe this is not true. Taking a while. Let's see, the best is 62. I actually suspect now that the best order is to reverse these, because you actually kind of want to like front load your ore building robots earlier. So oh yeah, sorry man, I completely missed this. So it's just a board game, man. This is we are trying to optimize a Euro game here. Basically, I can talk about this since I'm just run for a while. Basically, it's like having a board game with like different rules to make different units. So the goal is to get the most geodes. And in order to get geodes, you need to like have geo robots. Your geo robots are going to produce a geode every turn, basically every minute. But in order to make them, you got to get 2 ore and 7 obsidian, and so then there are robots that do each of those. And you start with just 1 ore robot. So every minute, it's going to get you 1 more ore. The question's kind of like, okay, do I need to like save up to get 4 ore so I can name another ore robot, or do I need to like kind of tech up, like spend the 2 ore that my ore robot collected and then play robot? Yeah, basically, geode is victory points. So they have like a bunch of different like blueprints, which are basically like different rules for the game, and so you're trying to figure out like how can you maximize your points in a certain number of minutes or rounds, right? So it costs 1 round. You know, it takes a turn to activate, where you spend your money and make a robot. Yeah, this one is kind of boring, honestly. I just am not like, right now I'm at a point where I'm just trying to reduce the search speed. And so what that kind of means is I'm trying to make it so I don't like obviously look at bad strategy. So one here is like what I'm trying to do is kind of like build in some heuristics, I guess, like some kind of nudges to say, hey, don't even think about this strategy under these certain criteria. Like in the first part, I just kind of coded up the rules, right? And I was like, just try all the things. Or I guess I still had some heuristics, but they weren't quite right. So it was like, one was like, if I can build obsidian, just always build it. And that turns out to not be a great strategy. And I think the reason is like still going very, very slowly. I'm gonna have to find something to do. Like I said, the nice thing is that this one, it's just like the test input is as slow as the real input, but yeah, I'm not really sure what to do. So this kind of should make it a bit faster. I think I need to tell it like, hey, if and like I'm like, hey dude, if you have too many like ore robots, like don't just keep making these stupid, like we don't need them, right? Bot count 0. Those are my ore robots. What's that? Yeah, it's like the code is just going through all of the states, but there's like too many options. Like, how do I make a good, how do I make a good, yes. Like, this should help, because this is like super cheap, so this could prune out like, I don't know, this could be a ton of, that could be like groundbreaking. Right? And so what if we just add this like stupid check to all of them? Yeah. And don't make more clay robots than like something cost. We could probably even be more efficient. The reason that we're saying this is our robot factory can only make one robot type per round. So if we're able to like replenish the full cost every round, then like you don't need that, right? Okay, this should actually be clay robot cost, and I'm gonna do like a max obsidian. And the reason that like these should really matter is that sorry, it's actually just and obsidian robot and max. These checks probably don't matter, but maybe a tiny bit. The only thing that obsidian asked. Good. The reason that these matter is these are like branching decisions on literally every turn. So if you can cut down a branch like at every turn, then get like it's exponential. So if I have 3 decisions and I go from 3 decisions at every turn, 2 decisions at every turn, it's like very, very different. So just to like pull this up, right, so this is 2 to the 32. So if I have to make 2 decisions each turn, and this 3 to the 32, so this number is like wait. But this actually isn't that bad. So the other problem with this is like no good way to know how I'm making, like if I'm making, because I'm like pruning branches out of my tree. I can't actually like even really count these very well. And count how many times I hit the end. That doesn't actually tell me anything. So yeah, this sucks. Actually, I want to do one more thing. Important. I don't even know if this ever happened. Okay, it happened regularly. Okay, then this is going to be important actually. So I need to go in here and give my thing for memory. So take. All right, let's see if that helps. So I just gave it 6 gigs of cache to work with. I'm not really sure. I don't know, man. So you play games, like what's a good heuristic for like what for like when I should or shouldn't buy a certain type? Like this one's optimal and it only I think it gets like two ore like two ore robots, but it's building lots of other stuff, right? So like I mean so in this one it's like two ore robots, 7 clay, 5 obsidian. I think it's like based on, you know, how much these things cost, I guess. Yeah, this is super boring. I'm curious actually about why it decided to get, or why like 7 is, like, are these kind of related to each other? Like maybe I'm trying to find some proportionality, right? Like if it's okay, do this. So alright, man. See you later, man. Yeah, thanks. Hopefully I can figure out these bots. I think this one's gonna be a tough one. So we'll see. I'll probably let this keep going, but catch you later, I guess. Alright. Alright, so the thing that's really tripping me up actually is this one. So like have 11 obsidian, 6. Oh, it's because we only had whatever was here. So we going into this we had 4 and didn't have enough to start. Hmm. This probably has to be less than or equal to. That's great. Oh, we got up to 53 though. That's good. So I do think this is helpful. Max. Yeah, I don't know. Don't quite know what I'm hoping for here. I guess do some basic here. What else can I do here? I want to know if So these costs actually. So the costs are so one thing I'm like kind of thinking about is like, is there a way for us to know that we only need like so I'm like, can I just solve this by hand? Like legit. This is like 4, 4. I don't actually know why this check matters. Okay. Where did it make a bad decision? Because at least we have an answer though. At least we have like, it thinks it did the right thing, right? So check this out. Horde, horde, horde. Make 4. Horde. Play. Play. I actually don't add. Go straight. Okay. So then it makes like just a bunch of seven in a row. Obsidian. Nothing. Obsidian, obsidian. Okay. $18 Lord wealth. Man. Kidding me. Okay. That sucks, dude. This sucks. Because this is not a good. I have to do the same. I have to do the same thing. So G. I mean, it's possible that a lot of this is like logging, so I can just this. All right. So I mean, like if this dot or now, I mean, these might not be the right criteria. Just see bottom, because there's a day kind of at the end. Then anything, and like. So less than or equal to 2x. Sorry, 2x the max cost. That's not, no. Max cost is 4, so this would have been. And I don't think this is a good criteria actually at all. But I mean, it's oh, but this is also kind of pruning. Whatever. I'll just do this. For a second. Go see if I can figure out how to do. Oh my. Yeah, I don't think I remember how to do routine. Means to finish eventually, right? It just is like pretty frickin' yeah. I can, but I'm just kind of poking around on some other code that I have while this is running in the background. Because one way to just do this faster is like to do, right? Like, so this is a different problem, but do they still have this? Happens. Try to put this in here. And 8 threads. Okay. It doesn't hate it yet. So let's try this. Find best. This is a Nothing that you just said is like, okay. Hmm. Oh, this part. Okay, so I can async. Okay, let's just do that, I guess. Flat map. Let's do that. So instead of doing this map, and then I want to do this thing like this. Okay. It's like, I don't know what you're talking about. No worries, no worries. Got to do all this. Still doesn't know about it? Peace. Okay. I might not actually have this. Next. No. Maybe this will. Maybe it's. Pretty with this. I don't even know if this is the right. Try. Yeah, we have those. Alright, this is so not cool. Using Gradle? Pen. See. Let's look at the structure. right now I'm in my idea. Like, oh my. I like somewhat inconsistent when it comes to routines. Alright, I just looked up are from me. On oh my gosh. There we go. It's still just so this is going like hot. Okay. I'm gonna start thinking about how else we can make it go faster. Because whatever we're thinking about. I mean, if I can get these coroutines, I'll take yeah, but no, I think the issue here not in an equal. So let's figure that part out real quick. Okay. So like then a routine. Sure. So let's go root. No. Yeah. Okay. That does what I want to do, but that's required. Inner table. Get issue here. Oh, aren't we in the code? Are we not? Mention functions. Turn is not allowed. Okay. Okay, here we go. And Mac. This is probably not going to be Mac. Okay, and doing also code. I don't think I'm doing this right, dude. It's like slapping coroutines. Figure out how this is actually called. Oh, run blocking. So it's actually run. It's like that. Okay, so this gets run. Oh, this is not. Okay, happy again. Yeah. Do this. Now something. Still be long. Learn anything? Routine? Oh, from fine. All right. About that. Let's just see if part one. Should run right because it's doing all of these in parallel. Let's see. go see what our we're looking for 1150. Anything, so that means oh, because wait, each one is on I don't know. Doesn't like this seems, but uh maybe faster. Oh wait, this but this doesn't really help. Yeah. I know. The problem is that, and the problem is that it didn't work. Let's see. It should be solvable. Like, the whole thing about having a code is it should be solvable, like, without doing this kind of thing. So we figure out how. Okay. Yeah, because you now got whatever. Yeah. Okay. What can we think about here? So with this one, the reason that we got tripped up is we got to a point where it said, hey, you can build like this one, right? It's like spend 2 and 7. Here we like had 2 and 7, but built city collecting. So, I don't know. I mean, I might just like maybe I can actually. Through go. Find this equals block. Be like return run blocking. And then we'll do the same thing. I just want to see if this works. It does, like, it would save us. Like, it seems like it could save us some time. Part one, we're like for each. I actually like acing. Get dot await on the work. Have done this. That right here. Oh, maybe it returns birds. What is he? Required iterable type variable R found for long. Okay. Oh, so wait, should this just be map? Oh. Okay. Result should be it's possible that creating all these objects is like costly, but I think that just but this seems like it's working. I'm just gonna let it run through just to make sure that I'm getting the result that I want. Okay. So I do actually wonder if I do, like, can I async this as well then? Things can only be called within a coroutine. Okay, because it took 100. So I'm just gonna try to make this run like faster. Doesn't do. Yeah. Like suspend functions. Okay. Okay. Alright, so lap coroutines. Still says it's running. No. For this. I get rid. Do I actually need 13? I just mark this as suspend. It really is that. What I want. Yeah. I'm just curious if I get rid of all of this stuff. Like, don't add any run fast. I'd expect that it does. It does. Like, I hope that it would run a lot. Hundreds. I don't know. When we originally ran this, it was. Kirby. Probably about a minute. See what back with. Okay, it has been a minute and this has not returned anything, so whatever this is doing. So I'm gonna undo that. Was this? I don't know if it was only that, but we'll see. Last time, within a few seconds. Oh wait, actually, I wanted to do that. Other one is the one that I didn't. So I think there's maybe just too many calls. Just oak. Let's go up and run. Oh. Do I have to call a wait on this? I'm so freaking. Oh, this is. Or. I don't know. At this point, I'm thinking just like I have a very slow thing. Let it run. I only need yeah, I mean, do this 3 at a time. I think that's probably what I'm just gonna do. Is let's see if this goes faster when I'm not doing. So I think just kind of like YOLO it and let it try or whatever. We're not doing a whole lot here, but I guess we're searching a lot more states. And when you do it another 8 cycles, it could be many times that, but I don't really have any smart options or smart thoughts. Some of those will get pruned out because like you can't buy obsidian early, and like we won't be trying to get over robots late. I mean, I don't know. Yeah. Took how long it took? Like they just call it here for the stream, maybe? I don't know. I am best scores in part 2. Yeah, I may just call the stream. And I'll print some stuff at the beginning here, just so we can try score and do ID. Oh, it also says we got or print out the blueprint. So I don't really have any like good dots here. I think I'm just gonna why is this? You need to do it. Just the same. So not really sure why. The launch. Oh, so let's see. Result. Let's okay. So doing this. Happy with go long. Now. Another. Yeah, it's Kotlin result launch. Okay, launch does not return anything, so you have to either use async and await. Oh, I see. That's what I was doing before. Await. Does this not do what like I think it does? I don't think it does. New coroutine context. should have figured this out before. Coroutine, context, multi. I think they just changed this too. I think that's part of the problem. Yeah. Yeah, I mean, number. Let's. Okay. So let's try it. Actually. That. With content, sure. Oh, maybe. Should be. Okay. Getting there, getting there. Definitely speed land. Part. Oh. Oh. I don't think it's all. Just seem. Yeah, this is what I want. Yeah, damn it. Maybe the issue before was I was actually queuing up a bunch of things, but like thread. Yeah. Um. Okay. And just wants the. I think if I hit start here. Okay. Oh, it is doing 8 at a time. Nice. Yeah. Now let's try this. But this should kind of finish in like, I don't know, 10 seconds. My computer lagging. If I get a different label or one name. Kotlin turns and jumps. I think I could be like now for sure you can. On this. Get up. That's weird. Next. Yeah. I don't know if this level of threading is. Right, like trying to go. Not. So. Still's going. Maybe I have too many threads. I think my CPU can only handle like threads. Letting this go for a bit, and then if we don't really get anything here, I'm gonna just yeah, I'll probably just let it run stuff and go out. This should work. Just, I don't know. I don't really have a good reason for why my stuff is slow. I mean, I know why it's slow. It's a big search space, and I haven't really done anything smart to prune it down, so I've just said don't make more robots than... Wonder if it's doing all of this, like since it's trying to cache stuff, it actually might be frickin' or multi-threaded, so I should have just like said whatever a while ago, honestly. I think this part is helpful, where it's running, like you can dispatch here, but like this doesn't, like this seems like too much. So I will just do in parallel. Like, I think the overhead of all these threads is much, like, not really spending more time threading overhead than actually, right? Check that out. Assuming that this kind of does what I think it does. It may not be the way to do it anymore. Like, do they have an... to use a dependency. I see. Oh, I probably didn't get the... No, that seems slower, honestly. Try to replace that. I don't quite understand. Like, Oh. Wait, can I just paste this into my Kotlin? Is that what it's trying to tell me? Like, I can just do this? That'd be weird. Gotta be. Let's just put this. I hope. Build files. But when I've done this in the past, it just has been I don't know, hasn't really worked that well. So this. Alright, we'll try this one time, and if we're not running any faster, I'm just on single thread for fine. Dependencies. Yep. Stored updating. Well, this will be another thing to look into. I think it should be faster. Like I thought I was doing multi-threaded stuff. It's certainly running the proteins in different order. I'm definitely not sure on this like dispatcher thing. Dispatcher for changing threads. Okay, with context dispatcher. Oh, work thread. What I did? Use single thread. There we go. Okay. This should work, right? Okay. My cool. Okay. Come on. Work, dude. Oh, this is on him. Like I said, I think I just have 4. I might be able to have 8. I have a pretty old seat. Hopefully each of these is like pinned to a specific thread. Otherwise you're gonna be like flipping around on all frickin' on all the like memory access stuff. No, they should actually all be in the it's faster. $30. Is that 20? Well, it's actually working on the last 5 already. Try best 30 now. 30. 22. Or sorry, 22. So not. There must. Code. Bro. That's not great. Yeah, the biggest problem with this is it straight up didn't. We're back. Yeah, just don't. Val result. So if I just with context, don't return it. Spin? Yeah, okay. Then I can just do launch. Say. Doesn't matter. This one is like just a total cluster. This is terrible. Now result. It's complaining just because we're not doing okay. Spend function should be called only from a coroutine. But launch. Yeah. Alright, what did I do before? This is ridiculous, dude. Okay. I mean, this doesn't... I just want to make sure that I have some frickin' result. That'd be the worst to get through all this and not have. Okay. Yeah, I'm probably just gonna let it run. We've been bumming around here for about 3 hours. Not really a lot of progress, honestly. But this kind of seems a harder one. So yeah, I don't know. I think I'm just gonna toggle over to part 2 here, and probably let you guys know how it goes tomorrow. Honestly, I think it's gonna be fine. I think that it's gonna be the correct result, and I will go about my day. If you learn anything about how to make it more efficient, you know, maybe I'll let you guys know, but I don't know. It doesn't like, it's not obvious, so I'm not even sure this is faster too, right? It like seems maybe a little bit faster, but kind of seems about the same. So just making sure that we answer like that. Yeah, so that's kind of it. I'm actually literally just gonna run this and probably wait, I don't know, it might take an hour or something, but I'll get some sleep and we'll come back tomorrow. Plan to make sure I set everything up correct. So not actually test. That's the real thing. And then this is the real thing. Not test. Part 2. Alright. Cool. Get you tomorrow on something more exciting. I promise I'll get this one done, and I'll catch you at that point. But this has been day 19 now, but after midnight. Yeah, looking forward to day. See ya.